Hello, everybody. Hope you are doing great and are very relaxed. We are going to be talking about 10.2 today, which is probability and likelihood. Okay, so by the end of the lesson, you should be able to determine the likelihood of an event, and you should be able to calculate probability. Don't forget, when we calculate probability, we put the answers in simplest form. Okay, so the probability, which we write P of the event, whatever it is that I'm asking you, is the measure of the likelihood that event occurs. Okay, now if I said to you today there's a 40% chance of rain, is that a pretty good chance? No, it's not really great. It's still pretty good, but they go on percentages from 0 to 100%, or if we make these into whole numbers, 0% is 0, 100% is 1. So likelihood ranges from 0 to 1. So let's just say that, if I said, what's the likelihood that we have a hurricane tomorrow? Well, do we really have hurricanes in Indiana? No. So that's 0% chance happening. So when it asks you specifically the likelihood, if it's 0, you have to write it's impossible. That is impossible. Make sure you guys are writing these in your notebook, please, because I will probably take a notebook check or ask you to send your notes. Okay, let's say, what is the likelihood that the sun rises tomorrow? Well, the sun is going to rise tomorrow. We might not see it, but it's going to come up. So that is 100% going to happen, or 1. So we have to say that that is certain. Okay? Now, if something comes up to be 50%, let's say there's a 50% chance of rain tomorrow, that is 1/2. So we say that's as equally likely to happen or not happen. That's what we say if it's 50%, or as likely as not. Sometimes they say as likely as not. Okay, well, what happens, like let's say there's a 20% chance of rain. That is less than half, but it's greater than 0. That is going to be unlikely. Anything that lies in here is unlikely to happen. All right, so anything greater than 1/2 but less than 1 is going to be likely to happen. Okay, so you got to make sure you read the directions. If it says what's the likelihood, you have to answer with one of those 5 responses above. All right, so it says, what is the likelihood, number 1, that you flip a tail on a coin? So think about it. What are the chances that you flip a tail? Isn't that 50-50, right? It's got to be a fair coin, of course. So you have to say that is equally likely or not to happen. Okay? What about number 2? What's the likelihood you become a pro athlete? All right, I know a lot of you think a lot about your athletic abilities, and maybe you're really improving during this time of e-learning. But realistically, the chances of any of us becoming a pro athlete, yes, it could happen, couldn't it? But it's way less than 1/2, so we would say this is unlikely to happen. And then, what is the likelihood that it will be warm tomorrow? Well, I'm going to tell you right now, the forecast for tomorrow is 72 degrees. Compared to below 0 and 0 temperatures, I think that's a pretty good chance. So that is likely to happen. And that's the way I like it, likely. Okay, so now let's move on to where we are finding the probability of an event. Okay, so if I said to you, what's the probability you flip a coin and you flip a tail, you would put that event right in there. And the way we do that, it's the number of favorable outcomes, and that was from lesson 10.1 that we did before break, over the number of possible outcomes. Okay, refer back to 10.1. So find the probability that you roll a prime number on a cube. Okay, well, so we're going to write the probability of a prime. This does not say likelihood, it says probability of a prime number. All the outcomes on a cube, 1, 2, 3, 4, 5, and 6. Well, we have to put how many are favorable on top. How many of these are prime numbers? Well, 1 is neither prime nor composite. 2 is prime, only factors are 1 and 2. 3 is prime, 1 times 3. 4 is not, 5 is, and 6 isn't. So we take the number of favorable, which is 3 over 6, and reduce it to 1/2. So the probability of rolling a prime number is 1/2. Number 2, probability that you select a heart from a deck of cards. Okay, remember we talked about this? There are 13 hearts, 13 spades, 13 diamonds, and 13 clubs. Remember, they all range from ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, and 2. So the probability that you pull a heart from the deck of cards, so we're going to go probability of a heart. Well, there are 13 out of there are 52 cards in a deck. And if you guys notice, 13 over 52, isn't that a fourth of the deck? So this reduces to 1/4. And then number 3, what's the probability you roll a 7 on a number cube? Well, so we go probability of a 7. Our outcomes are 1, 2, 3, 4, 5, 6. Well, look at that. There are no 7s. So the probability is 0 out of 6, which is 0. All right, let's do a little bit of practice here. Okay, so look at numbers 1 and 2. It says describe the likelihood. This says likelihood. You've got to read the directions of the event given the probability. There's a 30% chance that it will snow tomorrow. Remember, this is from probability ranges from 0 to 1, with this being half here. 30% we know is in here. So what is the likelihood? It is unlikely to happen. Okay, you solve a brain teaser 0.75 of the time. So 75 hundredths of the time, let's change 75 hundredths to a percent, which is 75%. So you solve it 75% of the time. So the likelihood that you solve it again, it's going to be likely to happen. All right, the next one's you randomly choose one hat from 3 green hats, 4 black hats, 2 white hats, 2 red hats, and 1 blue hat. Find the probability of the event. First thing I want to do is add up all these hats that are in the bag. So 3 plus 4, 7 plus 2 is 9, and 1 is 10, so there's 12 hats total. Okay, so choosing a red hat. So we want to know the probability of a red one. Well, how many reds are there? 2 out of 12, which reduces to 1/6. Choosing a black hat, so we put probability of a black one. Well, how many blacks are there? 4 out of 12, which reduces to 1/3. Now this one says not choosing a white. So if it's probability of not white, we can get anything but white. So there are 2 white hats. So if there are 12 total hats and 2 of them are white, we're going to have 10 that are not white out of 12. And again, 2 comes out of those and we get 5/6. Probability of choosing a blue hat. Okay, how many are blue in there? Well, there's only 1, so that probability is 1 out of 12. Not choosing a black hat. We want to know what is the probability of not choosing a black hat. Well, there's 4 blacks, so how many of them are not black? There's got to be 12 minus 4 is 8 out of 12. 4 goes into both of those and we get 2/3. How about not choosing a green hat? Again, not green means it could be anything but the 3 green ones. So there's 9 out of 12, which reduces to 3/4. Okay, and then the last one, it says the probability you draw a mechanical pencil from a group of 25 mechanical and wooden pencils is 3/5. There are so many ways to get this, you guys. So 3/5, that is mechanical over total. So remember setting up proportions. If we have 3 mechanical out of 5 total, we want to know what's that equal to out of 25 total. We want to find out how many are mechanical. Well, I have a proportion set up there. Remember proportions, 2 fractions that are equal. If I multiply that by 5, I got to multiply the numerator and denominator both by 5, and I get 15. Okay, you could have also taken 3/5 times 25 over 1. 5 goes into 25 5 times, and you get 15. Either way, it doesn't really matter. 15 mechanicals. Okay? All right, so that's lesson 10.2, and I just want to ask you, why was the fraction skeptical about marrying the decimal? Why was the fraction skeptical about marrying the decimal? Because he'd have to convert from fraction to a decimal. Oh my goodness, that's so funny. You guys have a great day. If you cannot see the notes from the front page, flip to the third page. I took a picture of them. So I hope this helps.